Okay, so this is the next report about what's my current progress. So probably the first thing you can see immediately is that I added some more hydrogen atoms with total of 100 now. I also more evenly distributed them so they wouldn't be all spreading from single point, creating too many collisions straight away, and as a result lagging a unit at the beginning. So just like smooth start. So my main issue in the previous video was that I had too many issues coming from Unity, and like there was issues of adding energy on collisions, issue of losing energy on collisions, and I tried to solve it all with inside of the collision handler. So, and I was doing it with this long and complex on collision enter 2D method, where I was doing a lot of stuff, and I kept fighting with it for today without much result. So, and it's just so many issues that are happening. It's like I was fixing one issue, but then the energy was still coming from other direction. I was fixing another issue, and energy was still losing in another direction. So trying to find and hide all of these leaks, fix all of these leaks in Unity physics engine would be a nightmare that I probably don't want to live through. So instead I decided to go with maybe less elegant, maybe, or maybe more elegant, depends on perspective, solution, but it works. So I called it an energy conservation watchdog. So basically what it does, it every 1 second the time can be changed. It basically goes and it knows what should be the total energy in the system. By default it's 40, and it also has a list of all atoms in the system, and it goes and every 1 second it checks through all of the atoms. It collects their current magnitude relative to the current total kinetic energy of the system. So, and then based on their relative velocity or energy, which is pretty equivalent here, it just adjusts them so that they would not go over the capacity, or for that sake under the capacity. So if the system somehow suddenly lost in energy because of some Unity issue, it would just increase the velocity slightly too, just so that they stay inside of this capacity. Yeah, also I just added a small single thing here in case if somehow we would lose so much energy that will go negative numbers. It actually gives very funny effect, but it's completely unrealistic, so I make sure that total system energy never goes below 0. Yeah, so let's see how it works. So yeah, let me turn off this for now, we don't need it yet, and let's start. So the system bumps in, it moves for a second a bit faster, and then it goes and sort of puts itself to this 40, the total energy that we have specified in our energy conservation watchdog. So, and as you can see, it doesn't speed up, it doesn't slow down, it keeps the energy, but at the same time all of the bumps and all of the interactions between atoms looks as normal as they should be, because basically all of the Unity collisions are still processed by Unity, just making sure that these collisions are adjusted proportionately to keep the energy in the system same. So I wouldn't say it's an equivalent of energy conservation in the universe, because it needs 1 second to kick in, and you still kind of can break it for if you're doing it fast enough. But I think it's close enough for this simulation and for our goal. So I can control as a result through this thing the total amount of energy in the system. So I can, for example, slow down the system even more. So I decrease the total number of energy, and it will be automatically applied. I can do the opposite, I can increase. So, and I can even, like what I was trying to do in the last video, I can increase it very fast. So here I can put it to 500, I can easily put it to 1000, making them move like really much faster. So yeah, as I usually do, I will try something that I haven't tested by myself, but let's put it to even much faster. Yeah. So yeah, we put it to 5000 total energy. So I guess we are having here the case of very hot gas or something, and it moves really fast. So, and we can very fast decrease it to relatively low value again. And yeah, we have it all here. So if you think about it, technically the movements and collisions between all of these guys is not getting very different with the change of the energy. They kind of just increase the speed of movement. So, and it actually kind of probably makes a lot of sense, because it changes the total internal speed of the system, but it doesn't really change what interactions are happening. It's like time machine in a way, if you think about it. Yeah. Anyway, so another thing that I did is I had a heat source in the past, so here, and as you remember, it was basically applying energy to the atoms that were floating in vicinity of the circle. The problem now would be that if I will do something like this, it will be increase of energy in the system without control, and what the energy watchdog will do then, it will like, okay, you cannot add energy in the system, that's not allowed, and it will just proportionately decrease the energy for all other atoms, which is kind of not what I want to do. I don't want to heat one atom while simultaneously cooling down all others. So that's why I updated my heat source code, and now heat source is also aware of the energy conservation watchdog, and whenever it produces some energy and heats up the flying by atom, it also adds this exact energy that it heated it by to the energy conservation watchdog, so that it would not protest new energy that appeared from nowhere, because it would know that energy appeared from some legitimate source. So let's see how it works. Yeah, so we basically, I think, can just turn on the heat source, and yeah, it starts slowly heating, and we can see that our energy in the system is now increasing, and yeah, it obviously needs some atoms to flow through it. Yeah, so it kind of changes gradually, but the more energy we put in a system, the more of the atoms will be floating through the heat source, and the faster it will be warming up as a result. So let's speed up this process a bit more so we don't spend too much time. So we're now adding much more, 10 times more heat in the system with every interaction with the heat source. And when the molecules are bumping into each other, they're transferring this energy to each other, making other molecules move faster. More of them are getting inside of our heat source, and all of the heating happening faster. So basically it's kind of becomes like a cumulative process. The faster it happens, the faster it goes. So it may be very slow at the beginning, but then as soon as all atoms are getting more and more energy, yeah, we can see how it's kinda starts increasing dramatically. And the funny thing is that because now we have the energy conservation law, we don't have a problem as in the past that energy was just suddenly disappearing somewhere somehow. Now the energy is just keeps increasing until we added more and more of it inside of our heat source. I think this is enough of the heat. So yeah, and we can see that I maybe turned off the heat source, but we still have all of the energy that we added in the system. So it's pretty good. I'm quite happy about what I have now. So my plan further, at least for today and maybe a few next days, is to research the topic of atom and molecule elasticity. I need to understand if we have two molecules or two atoms collide with each other, does they have an absolute elasticity and all of the energy will be just transferred as a kinetic energy, changing their velocities, or will some of this energy be transferred into radiation or into the light emission? So this is interesting, and this is something I need to research. I somehow doubt that it's an absolute elasticity, because then it would really cancel out a lot of existing physical effects, which doesn't sound realistic to me. So, but I would guess that probably the elasticity is pretty high. So yeah, some more physical chemical research. That's interesting. So another thing I need to decide, am I ready to start implementing covalent bonds, or I need to implement the heat transfer in the system on some even better level before I can go and start implementation of covalent bonds. Yeah, so that's a plan. Okay, so now before we finish, let's try to do some other thing. We will try to decrease the energy in the system by adding -5 heat. So basically we're now cooling down. So now this is our heat sink. It somehow stills. And yeah, and we can see that it just stole all energy from our thing. It actually did it probably too fast, and I think I can guess where it comes from. The reason why it happened too fast is because we managed to, when we were doing here, our delta could be our velocity, resultant velocity could be negative, and as a result it's managed to transfer the negative values to the rest of the atoms, and it's not correct. So I probably will play with it a bit too. Yeah, that's it. Thank you for watching, if you've been watching. Bye.